This project provides a user-friendly interface to improve performance and accuracy of linear content modeling. The user can specify preference by LCPERF keyword for performance preference or LCACCU keyword for accuracy preference. The user can also modify values of some specific control parameters based on the analysis requirements. The benefit of this project is to improve ease of use for Solution 101 linear content analysis by setting the best solution control parameters based on the keyword specified by the user. Okay, input is simple. Just specify LCPERF or LCACCU keyword at the first line of NL step bulk data entry. So only single line is okay. The user can also customize values of specific control parameters through LCNT at the second line. This table lists the default solution parameters internally by the program, where the keywords values are here. Means the original default without defining any step or any bulk data entry in the model. The values selected here by these new keywords are based on the test results and the suggestions from field engineers and QA team in India. There is no new output for this project. The test results show that the SCRF keyword improves the performance 2 to 7 times for field engineers as models compared to the current default setting of linear content analysis. The other keyword were LCACCU adds the displacement convergence criteria to improve the accuracy of results. Guideline. For some content models, they may have trouble reaching convergence because of single increment during analysis. In this case, the user can increase the number of increments to achieve optimal results. Limitation of this project. This capability is applied to Solution 101 linear static analysis with small displacement and small strain only. Here are two test cases. The first one is pin and crevice content bodies with the model geometry and the Van Mises stress contour shown here. This table compares the performance of the two keyword models baseline, where the baseline is was run without any step or any pump entry. So you can see the CPU time improved 5.5 times for accuracy preference and also improved 7.3 times for performance. The number of iterations also reduced significantly, so that the convergence speed improved 5.9 times for LCACCU keyword and improved 8.2 times for LCPERF. These are the results for three models. You can see that they are identical in maximum displacement and in maximum contact normal stress. Here's another ball and base model with the geometry and stress contour shown here. Again, this table shows improvements in CPU times and the improvements in convergence rate for this model. Here's the results of these three models. Although they have identical maximum displacement, the maximum contact normal stress for the ACCU reference is 0.05% difference from baseline, and is a 0.51% difference from baseline for the performance keyword. Okay, GUI support. Currently, neither Patron or SimExpert support pre-processing, but both software support the result processing. Patron may be able to support this feature in version 2011. For SimExpert, just 12 hours ago, I said future plan is uncertain, and then our SimExpert team is very efficient. They just get my slide, and then they plan to implement. So I should say the SimExpert support is underway. Okay, conclusion. This project provides a user-friendly interface because it is easy to specify keywords. It improves the performance of linear content analysis while maintaining solution accuracy. So we march down to the second project. The second project is a segment-to-segment content improvement. This project adds the following new capabilities. It supports finite sliding for deformable contact bodies and provides sliding friction with an optional non-symmetric friction matrix. As a result, the content modeling requires no step-master relationship and can still achieve continuous stress. The project also provides several new flags and parameters for finite sliding, including maximum allowed sliding distance, non-symmetric friction matrix selection, thickness ignorance, and the error calculation option. The users can benefit from being able to compute friction forces in segment-to-segment contact analysis. They can also simulate segment-to-segment contact with finite sliding. To specify segment-to-segment contact with finite sliding, just define method parameters with a seg large from the BC para bulk data entry. Besides this new method, the following 5 new parameters are introduced. Slide limit defines the maximum allowed sliding distance. SegSym flag allows the user to specify symmetric or non-symmetric friction matrix in segment-to-segment contact analysis. SegOff flag is used to ignore signals from the tolerance used by iSearch equal to 2 in node-to-segment contact or during the calculation of characteristic length in segment-to-segment contact. Error-based and option computer error globally or based on each pair of step master. DDU limit specifies maximum value of DDU in a Newton-Raphson circle. Note that SegOff and error-based, these 2 parameters are both applied to node-to-segment contact, segment-to-segment contact. There's no new output for this project. Guidelines. Some model may fail to converge while being converted from node-to-segment contact to segment-to-segment contact with finite sliding. To resolve this issue, the user can change augmentation method by setting augment equal to 1, 2, or 3 on BC para bulk data, and increase augmentation distance using the augdist parameter on BC para. Or they can increase penalty vector with a PENALT parameter on BC para. Limitations. Segment-to-segment contact with finite siding does not support black square analysis, thermal analysis, couple analysis with multiple physics, adaptive meshing. These features may be supported in future releases. Okay, here are several test cases. This model is a segment-to-segment contact of two blocks with friction and finite siding. The pattern of the large block is fixed, and the enforced displacement are applied on the top grids of the small block with the following value. The BC pair parameters are defined as follows, where friction is specified by F-type equal to 6 linear Coulomb friction, and the contact method is sec large. You can see the von Mises contour shows the pulling of the upper block in X in Y direction. This is an edge-to-edge segment-to-segment contact with finite siding, which shows a smooth displacement contour of the contact edge. These are edge-to-shear and the edge-to-solid segment-to-segment contact with finite siding. Again, the displacement at contours at the contact regions continuous. Screw support, same as the previous project. So we just say that both Tetran and SimExpert support are underway for pre-processing, and they both support the post-processing. Actually, it's very important for our software package to support this feature, because we need an integrated software. Conclusions. This project enhances the functionality of segment-to-segment contact analysis by removing the limitations of frictionless analysis and sliding. As a result, MD-Next will provide more accurate results for deformable contact bodies with about equal stiffness. That's the end of my presentation. Thank you.